Hi my friends. We all know that apart from bearings there are also ball screws. They reduce friction and ensure increased assembly precision. In this picture we see the three main components: the screw, the balls and the nut. Well, today we are going to model the nut. You see here that component which has a coil inside and some cuts. The drawing is here with all the data necessary for us to create the model. It appears here something special. It is an unfolded view of the cylindrical face, this face, in order to have dimensions for the cuts. When I say unfolded, I think to the folded. This is the folded, and this generator is down. We need this because we have to start from somewhere that cuts, and we have dimensions here. Number one cut or slot is this one, number one. Yes, so we have to consider this dimension 30 degrees for starting the other cuts. 1, 2, 3, 4, 5. Okay, we start by creating this revolving volume with dimensions 108, 76, 86, 104, but also these two features. We have here all the necessary dimensions. Let's start. In order to use this dimension 13.5, I create the first sketch with the center point aligned on this line, because this end of the cylinder is this left, right here line. Standard millimeters IPT, sketch, then the contour, which is as I create here. As I said, this will be aligned with the center point. Coincident, this line with the center point. Then I draw a center line which has ends, which is really center line, but it has ends associated with these end lines. Good. Now the first dimension, which is 104. home, and we have the real scale. This is 86. This is 2. The other is 10. And diameters. This is 36.4. The internal diameter for coil. This is 50. This is 76. The center line must be coincident with the center point. The other dimension is 108. And the last one, I don't get it. Oh, this one is. These 2 millimeters are also 50, like on the left. That's all, fully constrained. Good. Finish, revolve, and we have the first volume, my friends. This is. Next is this small cut, which is through 10 with 88.5, because we want to have the 30 degrees dimension based on something. Face, rectangle, 10, tab 85, 8.5. Then I place it with the midpoint on the same vertical with the center point, and tangent this bottom line with the projected circle. Okay, extrude. We select this with cut through all. Okay. Now, in order to place this dimension, we observe here that this is a view from the left to the right, so that we have to think about this angle, which is this angle. I select the face, I draw a line from this center point to the external circle, which will be 54, tab 30. I have to add 90 here, plus 90 to have what we want to have. Then I create a new plane based on this line and this end. You see the plane? I extend it to the whole part with the auto resize. Good. I hide the sketch because I have the result. Now, since we have 5 slots, I will make something new. I multiply in a circular pattern this plane about the x-axis, but not 6, 5. Okay, you see we have planes for all the 5 slots. As you can see here, the first slot is with the center at a distance of 13.5, and then 12, 12, 12 are dimensions around the D cylinder. Dimensions of slot are 14.5, the length between the centers, radius 5.75 at the end, and 59 the angle. Good. We select slot center to center. We draw a slope line of 14.5, tab 59 is the angle, enter, and 5.75 is the radius. As you can see, I entered 5.75. Escape. We have here all dimensions. And now you see the real value of 5.651. Then I apply placement on the same horizontal of the 2 centers. Center of slot, center point. Then also from this point to the center point, I place the value, the distance of 13.5. You'll see why I emphasize that border. Finish sketch, extrude, not join but cut the other direction to the inside cylinder so that we obtain a slot in the object. Since I use this plane, I hide it. Yes, we have a system, a procedure. Now we use this plane for the second slot. We have projected the center point. Yes, we want to use the previous sketch. Copy, paste, and we have this dimension 13.5 from this point, which was the center point. This is why I place center point to center point, then I change the dimension. Double click here and plus 12. Yes, Finish sketch. Extrude. Now we know the procedure. Cut to inside, and we have the second slot. This is consumed so that I hide it. We go to this one. We also select a sketch, but not this one, the last one. I close this to have no problems. Copy, paste, coincident between this point and this point, the projection of center point here, and adding 12 at the end, plus 12. Okay. Finish sketch. Extrude. Cut to this internal cylinder. Okay. We hide this plane. Visibility, and we go to the next one with a new sketch. I close this, I open the next, copy, paste, coincident this point with this point, double click on the dimension, and plus 12. Okay, finish sketch, extrude, cut to the internal cylinder. Okay, hide the last triangle plane, and we go to the last slot, which is obtained by using the previous sketch. Copy, paste, coincident, the 2 points, double click on 49.5 and plus 12. Okay, finish sketch, extrude, cut to the cylinder. Okay, hide the plane. Good. Next is the internal thread, this one, with dimensions here, radius 3.3 and pitch of 10. We use the tool coil for this, but first we have to select the plane XY to create the circle. F7, circle, radius, this is radius of 3.3. We select the intersection of this generator with this end. to start from outside the internal thread. This means that we select construction and the two projection. Coincident the center with this first line and then with the other. Finish sketch. Coil. It is already selected the close contour, and we have to place the axis. The axis is X. This is the axis, and the pitch is already set, the value of 10. The height, the distance between ends, is 104 millimeter plus 5 millimeters. Okay, but you see, be careful, we select cut, not join, of course. Okay, now we see the internal thread for the balls. Then we have to apply some holes. As you can see, there are 6 holes of 9 millimeters through equidistant. The start from this is here on the left. The diameter of the circle is 90. Okay, let's do this. We select this face and we select either left or right, no problem with this. Right is normal because I pointed that hole. The length is 90 divided by 2. Finish sketch. Hole. This end point is the position of the hole. This is the solution, and the hole is through. Yes, through. Diameter of 9. What is this? And we apply circular pattern for this feature about the axis X axis. 6 holes, 6 is by default. Okay, on the same face we have other 4 holes, but not equidistant. 30 degrees is this one, and the value is metric 8 through. 30 degrees, 1, 2, and then 3, 4. At 30 degrees, no matter left or right. Good. I select the face I apply sketch, I draw a single line, at the distance of 90 divided by 2, tab, nine 180 minus 30. Yes. Finish sketch, hole, end point, threaded, ISO, and through, as you can see here. Full depth is the thread, not the limited value. Then I apply mirror of this last feature about the plane. This one. Okay. And then both holes, but the plane is XY. Okay. You see there are metric 8, 1, 2, 3, 4. Okay, on the other side, this side, we have 4 millimeter equidistant of metric 5 with 2 depths for the hole and for the thread, 12, 15 and 12. Okay, the holes are this, you see, 1, 2, 3, 4. What is the circle? The circle is 64, my friends. Good. I select this face, line from the center to somewhere, 64 divided by 2 is the circle, tab, 45. Finish sketch, hole, this end point, metric 5, with not full depth and distance, so that we can apply 15, tab, I have to select this to be 12. You see here the hole with a limited depth of the thread. Then we apply pattern of this feature around the x axis, not 6 but 4. Okay. Next is this small hole, which has dimensions here, 10 millimeters from this end with 10 depth, 7 thread, metric 4. Let's create this hole. We select this face, we place a point here on the same horizontal with the midpoint of the side and a distance of 10. Finish sketch. Hole, not 5 but 4. And that two distances of 10 and 7. Okay. I didn't select the point. Okay. You see here that small hole. The last thing is the chamfer of 1 at 45 to both ends of the nut. This is chamfer 1 millimeter and 1 millimeter. We have finished the part, my friends. Here is a point because of a sketch. This sketch, yes, visibility. The material is stainless steel. Stainless steel. And I suppose everything was used. We can make a comparison. You see, nothing is different. Let's see what is the collapse. Solve children to have the browser in our vision, eye properties, physical update, and the volume. Close. I didn't select the 3 at the end, but this is not a problem. Oh, I don't have here a volume. Yes. Annotate text volume equal paste 3. Okay. That's all for today. Thanks for watching. Bye bye.